So you should open up your packet to number 33 is what we're on, and we'll just do this for 15 minutes today. And your points for this week are just based on how complete your packet is at the end of it. So as long as you're writing it down as I do it, you should be just fine. So we're on number 33. Give an example of each property using angles. So on the back of your note card, we wrote the reflexive property is when we say anything equals itself. This word reflects, or reflect means right back at you. So we would say measure of angle A is equal to itself. Or if we're using congruence, we'd say angle B is congruent to itself. But that's a reflexive property when it looks exactly the same on both sides of the equals. Symmetric says that if angle A is congruent to angle B, then on the back of our note card we said you just swap those and use symmetry, that it's the same on both sides. So we just switch the left side with the right side. For the transitive property, we'd say, well, if angle A is congruent to angle B and B is congruent to angle C, then. And I like to call this one skip the middleman. We're going to walk over B to get from A to C. So we'd say then A is exactly the same as C. So you'll need to recognize those properties in use with both angles. And now in blue, we'll do the same thing with segments. So the reflexive property would say segment, let's pick my two favorite letters, CD, is congruent to segment CD. It is congruent to itself. The symmetric property says that AB congruent to CD could also be written as CD is congruent to AB. They can swap sides. It's kind of like saying X is 3 and somebody saying, 3 is X. That's the same whether we flip the left with the right. So that's what the symmetric property says. The transitive property means we're going to walk through one to get to the other. So we might say AB is congruent to CD, and then we'll go from CD to another one. CD is congruent to EF. I'll let you get that written down. And I like to call this one skip the middleman. So we'll walk through CD, and we'll say then AB is exactly the same as EF. So these three properties we put on the back of your note cards yesterday, and you should have a pretty clear idea when and how to use them. This says fill in the missing steps to the proof. So if we were doing this in a drag and drop fashion, remember the first step in any proof is given. Algebraic proofs, what you do is generally the property that you would drag into this slot. So what did I do to get rid of this 2x right here? Because you can see it's missing. It means we must have subtracted it off. So it's kind of like the step you would do to solve it. We call this the subtraction property of equality. We drag this one into the box. What you do is generally the name of the property. So on this one, you'll notice that the 4 is gone. And to do that, I'd subtract 4. So this would be subtraction and then subtraction again. On the next one, we always start with given. And then what we do is generally the name of the property. So if I were solving this, I'd say get rid of the subtract 3, which is exactly what they did. It's now gone on the left, and 4 plus 3 is 7 on the right, and I add it. So I would put in the addition property of equality. Addition property of equality. The next one, to undo division by 5, this is x divided by 5. I multiply both sides by 5. What I do is generally the name of the property. So this one would be the multiplication property of equality. And you just drag them into the box. Number 37, we need to go to our note card. So we're going to stop for a second. You're going to go back to your note card. So I'm going to page back here. So find it if you didn't already. I'll give you a minute to find that and take it out. We're going to add some stuff about parallel lines and the names of some angles on the back of here. So if you need to pause the video, go ahead to find your note card. Once you have it, go ahead and hit play. So when we have two parallel lines cut by a transversal, 8 angles are formed. And I want you to put this on your note card. 1, 2, 3, 4, 5, 6, 7, and 8. The relationships that you need to know, we'll go put it up on the side, are corresponding angles. Corresponding angles are in their same spot in their group of 4. So if I were to go consider this as being 2 groups of 4, I would have the top group, trying to go to a highlighter here. It's the red one that went to a highlighter. There we go. So I'd have this top group of 4 in yellow. And then if I want to consider the bottom group of 4 in purple, corresponding angles are in the same spot, like top left, top right, yellow to purple. So corresponding angles in my picture would be that angle 1 corresponds to the top right and the bottom, which would be angle 1 and angle 5. They're both in the top right. Also corresponding would be, like, say, angle 3 and angle 7, because they're both in the bottom left. So it's top to bottom, they're in the same spot. So you might want to write same spot. Corresponding angles, too, are always equal. So I put it equal to in a box right here. All right, so corresponding angles are in the same spot, and they are equal to each other. Move that back over. I can't. All right, the next ones you need to know after corresponding are alternate interior angles. Alternate interior angles are in the parallel lines, so between the parallel lines. So interior angles would be 3, 4, 5, 6. Alternate interior hop the transversal. So that would be like angle 3 and angle 5, and also angle 4 and angle 6. They too are equal. So if one of them's 30, the other's 30. There's algebra in them, you set them equal. Alternate exterior are on the outside of the parallel lines. So that would be like angle 1, 2, 7, and 8, but they also hop the transversal. So 1, alternate interior with 7. Okay, so angle 1 and angle 7, they're on the outside, and they hop the transversal. Also angle 2 and angle 8. Also, after alternate exterior, we'd have what are called same side, some books call them consecutive, same side interior. Alright, so this word means we're in the parallel line, so again, in here, angles 3, 4, 5, and 6, but now instead of alternating, we're on the same side. So that would be like angle 4 and angle 5, and also angle 3 and angle 6. And again, alternate exterior are also equal. These, on the same side, add up to 180, just so you know the relationship. So back to, go grab my highlighter again. So we have corresponding, they're in the same spot and they're equal. We have alternate interior, which are inside but hop the transversal and they're equal. Alternate exterior, hop the transversal but they're equal, and then same side interior, which add up to 180. So if we were to draw this picture one more time on your note card, maybe a little smaller just so we're not taking up so much space. So let me go here for a second. Go back to my pen, let's do it in black. So if you were to draw two parallel lines, purposely make them go the other way this time, cut by a transversal, if I give you one of them, you automatically know all the others. If this is 100, so is the one that's in the same spot. So is the vertical to each of those. So you'll notice all of those are 100. The ones next to it make a line. So that's 80, 80. And you remember when we did these, we'd say they're the same along the zigzag. So you'll notice that when I zigzag, I go across, and then across, and then across. Those are all hundreds. The other ones are all 80s. So it kind of makes sense. So I'm going to pause this for a second. All right, so let's go back to the worksheet, and we will continue with those kinds. So back to the worksheet. We were on number 37. So these are two parallel lines cut by a transversal. It says, what's the relationship between angle 4 and 5? They are inside the parallel lines on opposite sides of this red one, which we call the transversal. So we call those alternate interior. So if those were the ones you had to select, you would click on alternate interior if you were taking a test. How about the relationship between 1 and 8? And we have it on the back of your note card, but they're kind of easy to figure out. We're outside the parallel lines. I'm going to do the parallel lines in blue so you can see we're not inside them, so I won't click anything that says interior. We're on the outside, and we're on opposite sides of the transversal. So we call those alternate exterior angles. Next one. If angle 2 is 110, find all other angles. Well, if this is 110, so is the one across from it, so is the one in the same spot, and so is the one across from it. If you head on a zigzag, those are the same. The ones that are next door add up to 180. So this would have to be a 70, so is the one across from it, so is the one across from it, so is the one across from it. So you'll notice these same side interior aren't equal. They add up to 180. But those would be all of the angle measures. So we'll write done. I did that. Now, when it comes to the algebra, you basically just have to decide, do we set them equal or do they add up to 180? So you have to kind of take a look at what kind they are and decide what to do with them. Angle 2 is 4x. So I'm going to go put that back on here. So angle 2 is out here, 4x. By the way, if they don't look equal, they're probably not, but angle 2 is 4x and 6 is 120. These look like they're the same measure. You can see it. Plus, they're called corresponding angles. They're in the same spot. And on your note card, we said those are equal. So you would just set 4x equal to 120. That's one way to do it. And then you divide by 4 and get x is 30. The other way to think about it, again, is using that diagonal method. This is 4x, this is 4x, this is 4x. So 4x is equal to 20. If angle 5 is 2x minus 10, so let's go see what we've got with angle 5. 2x minus 10 on the inside, so I'll be using one of my interior angles. Theorems probably. And 4 is 70. Then you have to decide if they're alternate interior, we set them equal. Plus they look equal, you can see it, they look very equal. If they were the same side, they'd add up to 180. So that would be 2x minus 10 equals 70. And I know you guys know how to solve that, so I'm just going to set it up. So the moral of the story with these is that you either set them equal or they add up to 180 based on what you wrote on your note card. The angles in a triangle always add up to 180 degrees. So if you need to find a missing angle in a triangle, you just use the fact that all of them add up to 180. So let's go take a look. All of these have to add up to 180 because I'm in a triangle. So I'll add the 2 up that they give me. I'm at 115 and I have x left. So I'd have to take 180 and remove that 115, leaving 65 degrees for the missing angle. Those 3 need to add up to 180 degrees. All right, next one up. A little trickier. I'm trying to figure out h. I know I have 180 for this one, and this one to share equally. So I'll obviously take the 56 and add this one to it. Same process as up here, but the problem is I have to figure out what this angle is down here first. And you'll notice these make a line together. So I would say 180 minus 1. There's an exterior angle theorem you can use, but I honestly don't think you'll remember it. So I think it's safer for you to just go ahead and do a little arithmetic. 180 minus 148 is 32. So now you have this guy right here, 56 and 32 at the bottom, and you have an unknown one at the top. So we'll add those 2 up. And we'll do 56 plus 32 is 88. That's what these two together add up to. So if I take my 180 and remove the 2 I already know, that'll leave me with 72 degrees. All right, so that one's done. Did I subtract that right? No, I didn't. Not 72. It'd be 92. Sorry about that. 90. It did feel weird to me. All right, so let's go to the back of your note card, and we'll add 2 things, and then we're going to be quitting right here today. So before you pack up, go back to the note card. We'll add 2 things to the bottom. So moving right along, angles in a triangle and up to 180 degrees. Totally true. And then I think just to start us off for tomorrow, we'll write one last thing. Slope of a line, we call it M. If it's on a graph, we look at how much we go up or down and how much we run. So if we have a graph, we can just do rise over run. If we're given 2 points, we do subtract the y's over subtract the x's. And that'll be it for today. So make sure you're done through that number, up to that number 44, and your note card is up to date for tomorrow. Have a good one.